Taking a bit of a break from the electrical work, in this video I'll cover off making new wheel spindles. As I said in an earlier video, the existing spindles are quite tatty. I could get them re-chromed, but it's expensive here in the UK and the chrome won't hide the damage to the surface, especially around the ends like here. Instead I'll make new ones from stainless steel, and from what I can gather, 431 grade will do just the job. The front spindle is a little more complex than the rear as it has this profiled section. Otherwise it's quite simple. The section that passes through the wheel is a nominal 20mm diameter, which when measured with a micrometer comes out at 19.88. The threaded part is M16 by 1.5mm, which is a fine thread rather than standard. And the final section on the left is a nominal 25mm, which I measure at 24.85. I start with this length of 1 inch grade 431 stainless, as I was not able to get any 25mm diameter, but the extra 0.4mm will likely help me, and when I measure it with a mic it actually comes out at 25.35. When turning I generally work with my collet chuck in my lathe, as it runs much truer than a 3-jaw. The bar is about 30mm longer than what I need, and I start off by facing off one end and centre drilling it. Next I rough cut what will be the threaded section, and I do this over length so that I can later get rid of the centre hole I just drilled. I am using cutting compound, which is causing the smoke that you are seeing. Not only does it lubricate the cut, but it helps in taking some of the heat away. To turn the main section down to diameter, I reposition the bar on the collet chuck and use a live centre to support the other end. I also use a ruler to measure out the length of this section. I'm not looking for high accuracy on these dimensions, only the diameters. To bring this section down to diameter takes many cuts. Stainless steel is quite tough and my lathe is only a basic Chinese import hobby lathe, so I'm taking off about 0.4mm from the diameter every pass. Even with such light cuts there is a lot of heat being generated. After my final cut, I'm getting a variation of 0.04mm along the length. Before removing the bar, I turn a short length of the far section down to 24mm. This is part of the profiled section. Swapping the bar around in the chuck, I mark out the full length of the spindle. I'm doing this with a set of vernier calipers working off the shoulder from the main spindle diameter I just turned. With around 10mm of material to remove, I take the lazy option and face it down to length. If it were much longer I would have used a hacksaw, honestly. To ensure that the diameter for the end of the bar, 24.85mm, is concentric with the main section, I clamp it via the latter. This is where working with collet chucks, assuming they have been well machined, brings significant benefit over 3-jaw chucks. For the profiled section, I do this very much freehand. Working off the end of the spindle for reference, I use a parting off tool to cut a slot at either end of the recess. Then, with some careful positioning of the tool, I fully open it out. I'm also able to add the chamfer at this end of the recess at the same time. For the conical section, I have set the compound slide at 20 degrees, but work mainly by eye. To finish off, I give the surfaces a clean up with some emery and add the chamfer to the end. Before I cut the M16 by 1.5mm thread, I need to shorten the stub and bring it down to the correct diameter. This time I do use the hacksaw before facing off to the correct length. This also gets rid of the centre drilled hole I mentioned towards the beginning of this video. Although the specification for an M16 thread does call out the major diameter as being 16mm, I turn this down to the same diameter of the threaded section on the original spindle, 15.81mm. I then add a deep chamfer for the lead into the thread and also add a chamfer to this end of the main section. Because I'm going to be cutting the thread in the lathe rather than using a die, I need to cut a slot at the root of the thread for the cutting tool. I have previously tried to cut M16 threads into stainless steel using a die, but with no success. The combination of the size of the cut, the hardness of the steel, and no doubt the questionable quality of the budget dies I have to hand makes this a no-go. Instead, I use my lathe with an appropriately profiled tool. I'm not going to go into detail of how this is done as it's quite an involved process. But if you are interested, I'll include a link below to a video in one of my other channels. To cut the slot in the end of the spindle, I move on to the milling machine. I hold the spindle in a collet block which I've clamped into my machine vise. For the actual cut, I use a 2mm thick slitting saw. The slot on the original spindle is 5mm wide and 3.5mm deep, but I'm only going to cut mine to 4mm wide. This does mean that I need to repeat the cut with the slitting saw lowered and then raised by 1mm from the centre. And I do this in 1/2mm increments. As a crude gauge I use a 4mm drill bit to check the width. To finish off I use a needle file and some memory to remove any burrs. And there we have it, a brand new front spindle made from stainless steel. The rear of course is very much the same, albeit a little bit simpler because it doesn't have the profiled section. For the next video I'll be back onto the electrics with testing and completing the loom. If you like this video please do give me a thumbs up and maybe even subscribe to the channel. Thanks for watching.